We see the brain as a universe. Everyone has his own universe inside their head, and the idea is that this observatory shows images and shows the workings, the inner workings of this very intriguing organic universe that we all have. Every human brain is different, so it's really difficult to study the human brain. It actually doesn't make much sense. We're all very different. We all do different things in life. We have different personalities, we have different passions, we have different jobs, and that's actually reflected in our brain. And whether it's nature or nurture, whether it is our brain that makes us do what we do, or it is what we do that shapes our brain, I believe it's a bit of both, of course. We're all very different. So when we started our brain mapping project, we realized that mapping one representative brain was not an option. Just like you couldn't really have one book representing the entire world literature, you cannot have one brain model representing humanity. So we decided instead, even though it is a much longer term and definitely a much more ambitious project, is to create a library of brains. Now the technology has advanced to, instead of a microscope, it's really almost like a very high-resolution flatbed scanner. You know, the speed, if you can imagine a document being scanned on a flatbed scanner, the technology of digitizing this histological or pathology slides, it's more similar to a flatbed scanner than a microscope. For us, what was important was to accelerate the process of digitizing the materials, because when you have hundreds and thousands of slides, you don't want to be held back. And so this new technology is very important, because to us at least, is because we have very large volumes of slides, and the project is ambitious. If you want to archive hundreds of thousands of slides that represent the detail in each of these people's brains, we need to create this archive in a faster way. We know that disease acts at the cellular level and at the molecular level. So MRI is really not enough to be able to explain what was happening in somebody's brain when there are symptoms of a neurological disorder. MRI, though, gives a diagnostic view. What's important is to be able to validate and to match that low-resolution view that we acquire with MRI with the actual tissue, with the actual brain. So the Human Brain Library has the MRI data for each individual, but because these individuals donate their brains eventually, there's also the actual proof, the actual state of the tissue, which we use to explain what MRI saw. So when imagine a patient for whom there is no cure nowadays, 10 years from now, 5 years from now, 2 years from now, a doctor who would have a similar patient under his care will have available MRI to do a diagnosis, but he will not really know. He can be inside his patient's head. So by comparing his living patient that is here now with another who has donated the brain in the past, he'll be able to make predictions. He'll be able to give a better treatment.